Welcome back to this lecture series on deep learning. In this lecture, we'll discuss about the basics of AI, ML, DL, and neural networks, and why we should study artificial neural network, ML, DL, and neural network is because they are transforming the way we live, work, and solve problems. These technologies power smart assistants, self driving cars, medical diagnosis systems, recommendation engines, and much more. Learning them opens up opportunities in high demand fields and helps us build intelligent systems that can analyze massive data, make predictions, and automate tasks. Understanding these concepts also enables us to innovate, make informed decisions, and stay relevant in the fast changing technology landscape. They are not just tools of the future, they are shaping the present. Let's see one by one. This is the comparison table of AI versus ML versus DL versus neural network. The first, we'll see the definition. Artificial intelligence. Artificial intelligence is the overarching concept that refers to machines or systems designed to mimic human intelligence. This includes reasoning, decision making, problem solving, perception, and understanding language. Coming into the machine learning, ML is a subset of AI that focuses on the idea that machines can learn from data, identify patterns, and make decisions with minimal human intervention. And deep learning DL is a further subset of ML that uses layered structures of neural networks to process data in complex ways, allowing the model to learn representations directly from raw data, raw inputs. And neural networks are computational structures modeled after the human brain. They form the core of deep learning and consist of interconnected layers of nodes, that is neurons, that transforms the input data through weights and activation function. Next aspect is the scope. Coming into the AI is the broadest field encompassing everything from simple rule based systems to highly intelligent agents capable of autonomous behavior. It includes machine learning, deep learning, natural language processing, robotics, and more. Machine learning, if you are coming into, being a subset, focuses specifically on algorithms that improve through experience. That means data. It is narrower than AI, but still encompasses a wide range of models and approaches. Next, deep learning. Deep learning is more specialized, still concerned with the neural networks that have multiple layers, deep structures, and is particularly effective for high dimensional data. Next, neural networks themselves are the foundational models used in deep learning and some advanced machine learning systems. Their scope is purely structural and algorithmic within the broader ML and DL hierarchy. Next aspect is the learning type. The AI systems, coming into the AI system may rely on either symbolic reasoning, that is rule programmed by humans, or learning based approaches like ML and DL. Early AI systems were largely rule based. Next, coming into the machine learning, it involves learning from data, typically through statistical algorithms, without being explicitly programmed for each scenario. It requires structured data to identify patterns and make decisions. Next, deep learning. It relies on layered neural networks that automatically discover representations in data, especially unstructured data like images or text. It does not require manual rule definition or traditional feature engineering. Next, neural networks learn by simulating how biological neurons functions through weight adjustment in response to data, enabling the system to refine outputs over time. Next, future engineering. Coming into AI or feature engineering, in traditional AI or rule based systems, features and rules are defined manually by experts. This can be time consuming and rigid. Next, machine learning. In machine learning, significant human effort is required to pre process data and extract meaningful features. For example, in image classification, you might need to define shapes or edges manually. And deep learning, if you are coming into models, remove these requirements by automatically learning features during training. For example, a convolutional neural network learns to detect edges, textures, and objects without explicit programming. Next, neural networks achieve this through layer wise learning, where the lower layers detect simple patterns and higher layers combine them into complex representation. The next aspect is the data requirements. AI intelligent systems, AI systems based on logic or rule can function with little to no data but lack adaptability. And coming into the machine learning, it requires moderate amounts of structured, labeled data to perform effectively and generalize well to new situations. Deep learning demands vast amounts of data, especially labeled data sets, to achieve high accuracy, particularly for complex tasks like image recognition or language translation. Next, neural networks data requirements vary with their complexity. Shallow networks may work with small data sets, and but deep networks need massive amounts of data to avoid overfitting and underperformance. Next, computational power. Coming into AI, traditional AI systems can often run on minimal hardware depending on complexity. Next, machine learning. It models usually requires moderate computing resources for training and inference, especially for models like decision trees or SVMs. And the deep learning, however, require high-end GPUs or TPUs due to the intensive matrix computations needed during training of deep neural networks, especially with large data sets and complex architectures. Neural networks in general, particularly when deep or resource intensive, because each neuron processes and passes on information, often requiring parallel computation and high memory bandwidth. Next, human involvement. Coming into the AI, especially in its early form, heavily relies on human coded rules and logic to function. Machine learning reduces the need for manual coding but still requires significant human input in preparing data and engineering features. And deep learning minimizes human interventions the most, as that model automatically learns relevant features from raw data, greatly simplifying the modeling pipeline. And neural networks also rely more on data than humans. Once the architecture is designed, the network can learn through training with little manual oversight. Next, output. AI systems are generally focused on mimicking intelligent behavior, such as controlling robots, playing games, or managing conversations. The output is often an action or a decision. Next, machine learning. The output of the machine learning is the machine learning system typically produces predictions, classification or regression result, such as identifying spam emails or predicting stock prices, etc. And coming into the deep learning, it offers more advanced outputs such as understanding and generating language, identifying complex visuals patterns, even creating realistic images. And neural networks generate outputs based on their learned weights and structures. These outputs can be raw predictions, transformed features, or decisions depending on architecture and task. Next, the coming into the example, of AI system. Examples of AI include self-driving cars, virtual assistants like Siri or Alexa, intelligent chatbots, or robotic systems. These often combine ML, DL, and other components. And machine learning example is applications include email spam filters, recommendation engines like Netflix or Amazon, or credit scoring systems. And deep learning powers more complex applications like facial recognition, automatic language translation, medical image analysis, and speech to text system. Next, neural networks are used within DL applications and come in various forms like convolution neural networks for images, recurrent neural networks RNN for time series or sequences, or GAN, generative adversarial networks for content generation. Next, relations. Coming into AI is the broadest concepts and includes everything else in the hierarchy. Machine learning is a subset of AI that focuses on data-driven learning, and deep learning is a further subset of ML that utilizes deep neural networks to achieve greater accuracy with the complex data. Next, neural networks are the fundamental units used in deep learning and to some extent in traditional machine learning, forming the computational backbone of model AI systems. Next, coming into the conclusion. See here, ML is subset of AI, DL is subset of ML, NN is neural network is subset of DL. So in summary, artificial neural networks, what we can say is artificial neural network AI, machine learning ML, deep learning DL, and neural network are interconnected concepts that form a hierarchy of intelligent computational systems. AI is the broadest field aiming to create machines capable of mimicking human like intelligence. Within AI, machine learning provides systems the ability to learn from data and improve over time without being explicitly programmed. And the next, deep learning takes this further by using complex architectures of neural networks to automatically extract and learn from large volumes of data, especially unstructured data such as images and natural languages. Next, neural networks in turn are the foundational technology that powers deep learning and inspired by structures and functions of human brain. And each layer in this hierarchy, AI, ML, DL, NN, adds more capability and complexity, enabling machines to perform increasingly sophisticated tasks from basic data classification to real-time speech translation and autonomous driving. Understanding the distinctions and relationship between these terms is crucial for grasping how modern AI systems function and how they are applied in real world scenarios across industries like healthcare, finance, manufacturing, and entertainment. As data availability and computational power continue to grow, these technologies will only become more powerful, paving the way for even more advanced and intelligent system. Hope everyone understood the concepts of AI, ML, DL, and neural networks. The remaining things we'll discuss in the next lecture. Thank you.